Okay, so let's continue with the reverse primer. This is exciting, right? Now, let's do the same steps. Remember, we need to count 50 base pair bases. And for example, this is this sequence. It looks okay. It begins with G. It ends with G. So we pick the sequence here and Control C. But instead of going directly to Oligo Evaluator, you need to reverse your sequence, because remember that it's the reverse primer, so we need the reverse complement. So now, please get into the next page. And here, excellent. So you're going to choose your sequence. Excellent. Paste. I'm missing this bit. And paste. Now you're going to click reverse complement. They will give you, the page will give you the sequence that you need for your reverse primer. So this will be your sequence. No, not this one. No, this one. Now, let's pick this sequence and do the same now using the Oligo Evaluator. So, we paste the reverse complement and do the same. Calculate. Okay, excellent. Very weak, okay. Primer dimer, no. GC clamp 2, okay. 20 base pairs, so it's okay. 63, and so it's okay. So approved, right? So we go to the Excel. Oh, this is the other Excel. And paste here and put wrong X3. Oh, sorry, here I made a mistake. It's wrong X3. Wrong X3. Exon 2, reverse. And you do the same. You paste. So you can have all the information. Excellent. So as you can see, we already have our primers. But how can we make sure that they are not SNPs and they're okay, or if they are, how specific are they? Are they going to maybe match with another sequences? So how can you evaluate that? Oh, don't worry, there is another page to do that. So here, this is something that we call a SNP check. Now, copy paste. This is kind of slowly. Come on. Ready. Excellent. Okay, so we need to get our both primers in this same space. But how do you do that? Here in the page, you can see here a sample input. So they are asking you, this is the format that you need to get into the box. So let's write down here. I made you here a mauve. So you're going to put here exon, it's exon 2, and I'm sorry, this is just one, exon 2, and the format. So it's wrong X3 RON X3, E forward, like this. We're going to put it together. And this one. Paste. And together. Okay, this is our format. This is our forward. This is our reverse. And this is the chromosome. So we know that RON X3 is in chromosome 1. So we need to put 1. Okay, so this is our format. So let's erase that. Copy. Space. Copy. Space. Copy. And 1. It doesn't matter here the amplicon size, you'll just leave it on the default and snip check. So what this page is going to do is going to evaluate the efficiency of the primers, if they are specific, if they are not going to have SNPs, or if they are not going to match to another hits. So it's very important for you to use a cutoff of here I'm going to go back to the presentation, a cutoff of 50 to 100 hits. If the primers have more than 100 hits, that means that the primer is not specific, and so you need to evaluate your primers and do them again. But as you can see here, now there's good. There are no SNPs, so that's very good. If there were SNPs, that is bad, because that means that your sequence, your primer sequence is not going to be specific. So this is no SNPs, that's okay. Okay, excellent. Look here. The 100% hits is going to have one. It's going to be very specific to your sequence, and to other hits, it could be probably they're going to stick to another hits, to other 6 and other 43. Since our cutoff is to 500, to 50 to 100, that means that our primers are perfectly okay. So what you do now is just